All right, so in this video, we want to find the equation of this log function over here. And this is a pretty difficult log equation because we actually have to find the equation in terms of a, then the base as well is something we need to find. Then we need to find the k value, and then we need to find the d value and also the c value. So a lot of things to find in this one. So this is a pretty difficult finding of a log equation over here. So I'm going to show you the steps to find a log equation for this kind of question over here. The first thing you want to do is you want to go over your log graph and you want to find the first whole numbers possible. And you want to highlight the first three whole numbers. So in my case, it was these 3 points over here, which I've highlighted. They're the first whole numbers to the left of the asymptote. That's really, really important. Once you get these 3 points, we're going to use these 3 points to find pretty much all of these variables, and we're going to use the asymptote over here for the d value. So automatically we can sub in the asymptote for our d value because our d value is always our vertical asymptote. So I can just rewrite this as a log b k x minus 6 plus c. Figure out one of my variables. The next variable you can easily find out, I guess, is the c value. And for the c value, you can just look for the point over here. And remember, this point for a regular log function, the first whole number, if I draw a regular log function over here, oops, that's a negative log. So that's a log function right there. And the first point on the right of the asymptote of 0 is just positive 1. So to figure out how this function has transformed from here, my point was normally over here. Now this first point has transformed over here, which means it has moved down 1 unit, which means my c value is just negative 1 because the vertical translation down by 1 units. We don't have to worry about the horizontal translation because the k value will take care of that. And we already have the horizontal translation here from the asymptote. So don't worry about the horizontal translation of the point, only the vertical translation of this key point moving to this location, which is 1 unit down. So I can rewrite this as a log b k x minus 6 minus 1 to signify 1 unit down. The next thing I'll find is my base in this function. In order to find my base, I have to look at all 3 of these points and find the distance of these points from my asymptote. So my first point right here, this is a distance. So the asymptote is at 6. This point is at 4, which means this is a distance of 2. My second point right here is at 0. So this is a distance of 6. And then my third point right here is at negative 12. So this is a distance of 18. Now, if we look at the common ratio between these three, 6 divided by 2 is 3. 18 divided by 6 is also 3, which means that my common base is going to be 3. So I can rewrite this as y equals to a log base 3 k x minus 6 minus 1. So now I just need to figure out my a value and my k value, and then I'll have my entire equation. So in order to do that, I want to just sub in points and solve using substitution. I'll do that down over here. I'll start by subbing in this point into this equation over here. So y is 1, a log base 3, a x is 4. So 4 minus 6 is negative 2. minus 1. And simplify this a bit, log 3. This is just negative 2k minus 1. And if I move the negative 1 to this side, it just becomes, oh, I labeled this point wrong. That's a negative 1, by the way. It's below the axis. This is actually a negative 1, negative 1. This is going to become 0. Okay, now I'm going to do it with my second point over here, 0 and negative 2. So I'll replace y with negative 2 and x with 0. So 0 minus 6 is just negative 6. I'll move this negative 1 to this side. So it just becomes negative 1 equals to a log 3. This becomes negative 6k. So now I have two equations and I have two variables. I just have to solve by substitution over here. So for me, the easiest variable to isolate would be the a over here because I can just divide this on the other side. In this case, I can't isolate a over here because if I divide this on the other side, you can't divide 0 by this. It'll just disappear and then you won't be able to solve this. I'm going to divide this on this side here to isolate for a. So negative 1 over log 3 negative 6k equals to a. Then I'll substitute a over here for this. So 0 equals negative 1 over log 3 negative 6k times log 3 negative 2k. Now I'll just multiply these two to simplify it. So negative log 3 negative 2k divided by log 3 negative 6k. Now I just have to solve this equation for k, so I'll just multiply the denominator across with 0. It just disappears, negative log 3 negative 2k. Divide both sides by negative 1 log 3 negative 2k. I'll move the log to the other side, so the base comes over here. This becomes 3 to the power of 0 equals negative 2k. 3 to the power of 0 is just 1. And then divide both sides by negative 2. So I get negative 1 over 2 equals to my k value. Then I can come back here and substitute my k to find my a. So negative 1 over log 3 negative 6 times negative 1 over 2 equals to a. Negative 1 over log 3, 6. Negative 6 times negative half is just 3. Log base 3 is just 1. Negative 1 divided by negative 1 is just negative 1. Negative 1 divided by 1 is negative 1. So many negatives there. So now I've found all my variables. I can rewrite my final equation as y equals negative log base 3. Then my k value is just negative 1/2. Then I have x minus 6. Then I have minus 1 at the end. And that is my final equation.